Right, we need to understand perpendicular and parallel lines. If lines are parallel to each other, so if we have our Cartesian plane, XY plane, and we have lines that are parallel, I think it's easy to see all those lines would have the same gradient. We can draw a triangle underneath that line, and the rise divided by the run would be exactly the same as the rise divided by the run, and so on. So all these lines, if they are parallel, and we use arrows on the lines to denote they are parallel, have the same gradient. So parallel lines have the same gradient, or the same m value. That's parallel. Perpendicular lines, we've got two lines and we know they are perpendicular to each other. In other words, they meet at right angles. And we know the gradient of this line is m1 and the gradient of that line is m2. So we've worked it out as a fraction. We know what the gradients of these two lines are. Always m1 multiplied by m2 equals -1. If you multiply the two gradients together, we will get -1. For example, in this case, let's just say m1 is equal to -1/2, and in this case that looks like, m1 would be +1/2. It's rising as we go left to right, and m2, because it's falling, it would be -2, because when you multiply those two together, the 2's will cancel and would be left with -1. So if m1 is 1/2, m2 would be equal to -1/2. So if you know the gradient of one of the lines and you know the other line is perpendicular, then you could work this out by rearranging that equation. So let's do two examples that show you how these work. So let's look at the parallel lines. So parallel lines have the same gradient. Now we're going to use y minus y1 equals m outside of x minus x1. So we need a point that the new line is going to go through. Here is my point. We're told that it passes through -4, -2. And we're also told that it is parallel to this line. Now this does not tell us the gradient. We need to get it in the gradient intercept form. So to do that, we need to take 8 from both sides, and we get 3x minus 5y equals -8. We then need to take the 3x to the other side, and we get minus 5y equals -3x take 8. And we want to get y by itself. We don't divide by 5 because that'll give us -y. So we've got to divide by -5. If we do that there, we've got to do it everywhere else. Divide it right through by -5. So we get y equals, those -5's will cancel. Negative divided by negative is a positive, so we still get 3/5x. And negative divided by negative will give us positive 8 on 5. So that is the gradient of this line here, 3 on 5. So we've got our m value there, we've got our x1, y1, so away we go. So we go y minus y1, why did I put 2 there? It should be y1, x1, y1. So y minus y1 is -2, y minus -2 equals m, which is 3 on 5, outside of x minus -4. Minus minus becomes a plus, equals 3 on 5 outside of x plus 4. Y plus 2 equals 3/5 x. Now when we multiply that out, that's like over 1, so that'll be 12 on 5. So y, take 2, is 3 on 5x. Now 2 is, we're going to make it over 5, so multiply top and bottom by 5, and I'll get minus 10 on 5. Minus 10 on 5 is like minus 2. So we get y equals 3 on 5x plus 12 on 5 minus 10 on 5. It would be plus 2 on 5. Alright, so there's the equation of the straight line, which passes through negative 4, negative 2, and it is parallel to this line. And this line has a gradient of 3 over 5. Certainly they both have a gradient of 3 over 5. And what you could do is substitute in x equals negative 4, which we know negative 4, negative 2 lies on. If we substitute in negative 4 for x and calculate it, we should get a y value of negative 2. But you can check that, don't fudge it, just put x equals negative 4, work that out. If it's not equal to negative 2, maybe there's a mistake back there. Okay, now the second one. Find the equation of the line through that perpendicular to that. Now once again we start with y minus y1 equals m outside of x minus x1. We have a point on our new line, so this is my x1, y1. And we know this line has a gradient of 2 over 5. So we know that m1 times m2 equals negative 1. This is the equation of the line. We've got this line. We want to find the new line, so we'll let it have a gradient of m2. So we've got 2 on 5 m2 equals negative 1. Now how do we get m on 2 by itself? Well, I can multiply right through by 5. They will cancel, and I'll get 2m2 equals negative 5. Divide by 2, divide by 2, and we get m2 equals negative 5 on 2. There may be people can go a bit quicker with that, but anyway, that's a surefire way of getting there. So we've got our m value. So we've got this one here. We've got m, and we've got x1, y1 from up there. So now we can do the substitution in. So you've got y minus 4 equals negative 5 on 2. This is the gradient of the new line that's going to be perpendicular to that one. Negative 5 outside of x minus, and x1 is equal to 3. Remove brackets first. Y minus 4 equals negative 5 on 2x. Now minus times that minus 3 will be a positive 15 on 2. That's like 3 over 1, so it's negative 5 times negative 3, positive 15 over 2 times 1 is 2. So y, add 4 to both sides, equals negative 5 on 2x. Now it's plus 15 on 2, and 4 is like 8 on 2. So that 4, which is 4 over 1, multiply top and bottom by 2, and we get 8 on 2. 8 plus 15 is 23 on 2. Alright, so there's the equation of the line. Perpendicular, so this line here is perpendicular to that line, and it certainly passes through 3, 4. You can do the substitution in, put 3 in for x. That's a 23 there. Put x equals 3 in there and work it out, and you'll find that y is equal to 4. Certainly when you multiply the gradients, 2 on 5 times negative 5 on 2, you're going to get negative 1 when you multiply those two together.